Swayam Prabha. Digital India. Educated India.
Okay, so we talk about triple DS. So we have seen that DS has some problems. The DS is broken. So DS has some issues with the S boxes. Those are not, I mean, some non-linearity problem. We'll see those details. But DS is broke. I mean, and the main problem was the key size is just a 56 bit. So that is also a security issues in terms of the exhaustive search attack. So we can mount the generic attack on DS. So DS is broke. So now we need to have a replacement of DS. So DS, so people thought of that time to, instead of building a new block cipher, so why don't you try to use the DES and have a new block cipher which could be better than DS. So this is called triple DS. So basically idea is we will use the DS 3 times. So this is the triple DS encryption. So here we have key is basically key has 2 parts, K1 and K2. So the here key size is, so each is 56 bit. So it is basically 112 bits. This is the key size for triple DS. So we just break the key into 2 parts. This is 56 bit and this is 56 bit. Basically we want to use the DS. So this is the plain text X. Now we apply the DS encryption. Encryption of DS with the key K1 and then followed by a decryption of DS. This is the DS decryption with the K2 and then we will use the DS encryption again with K1 and finally we got the Y, the ciphertext. So this is the, so this is the triple DS encryption. So we have a key K which we are which is basically K1 and K2 concatenation. So this is the input. So this is the block cipher. So this is the block cipher. This is the encryption of triple DS. Encryption of triple DS. This is called triple DS because we are using DS 3 times. Okay. So now, and the key size is okay. Key size is reasonable. K. Key size is, size of the key is 112 bit. So it is difficult to think of the exhaustive search attack even if we have many processors. So parallel compare, even the time memory trade off attack would not be possible for this. So now what is the number of rounds over here? R, because for each of these DS is having, each of these DS encryption, decryption, encryption, each are having basically 16 round. So basically total we have 48 round. No, the 16. So this total we have, yeah. So 48 rounds. Okay. So 16 into 3. So 32 plus 16. So 48 rounds. So that is a major drawback of this attempt, because it is a huge time. 48 round block cipher. Nobody will be accepting this. So because each DS round is a little complicated in the sense that it is having those S boxes which is not properly documented, how it is coming. And moreover, there are another issues that non-generic attacks. Those non-generic attack can be mounted on DES. DES is broke by differential attack, linear attack. So, those type of attack can also be mounted here. One can think of that, because this is basically underlying block cipher is DES. So, if DES is broke by the differential attack, linear attack, so one can think of those attack on this triple DES. Okay. So, this is the encryption. So, what is the decryption? Decryption is just we have y is the input. So, for decryption we have to start from here, we should get back x. So, we have to reach here. So, for that we will use the DES decryption using the key k1. So, this is the DES decryption using the key k1, then we reach here, then we are using decryption. So, we have to use encryption. Encryption is the inverse process of decryption. So, DES encryption with the key k2. So, this will reach us here. Now, we have a encryption. So, we have to use decryption using the same key k1. So, that we will come back to the x. So, this is the decryption of DES using this k1, and we will get back this x. So, this is the decryption process of triple DES. Okay. So, this is the, so we have the key input, key is k1 XOR k2, I mean concatenate with k2. So, this is the decryption of triple DES, but it is not very interesting in a sense that number of round is more, and also the generic attack can be mounted on this. So, people did not like it very much. So, they wanted to have a replacement. So, now DES is replaced by AES, Advanced Encryption Standard, that is the RINDEL. We will talk about RINDEL in few later lecture. Okay, so, this is the block cipher triple DES, which is basically a 64-bit block cipher, and the key size is 112, and the ciphertext is 64-bit. So, this is the plain text, this is triple DES, and this is ciphertext, and this is the key. But inside we have 48 rounds. That is the major problem with this, because we are using 3 times DES. Okay. Okay, so, next we will talk about modes of operation on block cipher. Okay, so, this is under symmetric key crypto system. So, Alice and Bob, they are communicating with each other, and they have a common key k, that is the secret key they have. Now, suppose Alice is having a plain text, which is a long plain text, a long message. Okay. This is the message, this is the plain text M for the message. Now, suppose Alice they want to use the block cipher for their encryption purpose. So, they have a block cipher. So, they have a say L bit block cipher, L bit block cipher with the key size is same key. So, this could be DES, AES, SPN depending on L. I mean, if it is DES, L is 64-bit, if it is AES, L is 128-bit. So, but they have a block cipher, they agreed with the block cipher. and then they want to use this block cipher for encrypting this message M. So, what Alice will do? So, Alice will break this into L bit blocks like this. So, last block may not be L bit, maybe we have to append some dummy bit over there in order to apply this block cipher. So, then this is L bit. So, now we can very well apply this block cipher. Our block cipher, we use K, the key, and this. So, this is say x1, x2, x3 dot 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 something like that. So, this is y1. Okay, so on this also using the same key K. This is basically block cipher, same block cipher, and this is y2 K, this is y3, this could be ds or AES depending on the size of L. Okay, so this is the block cipher, this is block cipher encryption. So, we get this y1, y2, yn. So, this is the encryption, and Alice send this y1 concatenate y2 concatenate y3 to Bob, and Alice mentioned the length of this message. So, what Bob will do? How Bob can decrypt it? So, Bob has this y1, y2